This time on Captain Castle's laboratory, we're going to be working on the Department 56 Empire State Building. Which, here's the side of it, because this thing is big. There's the top of it, which is, I don't know, 7-8 inches from my camera. So the problem with it is some of the lights don't work. The ones up around the top work fine. There you go. And the red light works. I'll move that. But when I press the button right here for the green or the blue, I got no green and no blue. I got red though. So I don't know if it's a bad circuit board or if it's a bad LEDs. So if you notice, this one's like crystal clear, and then these two are really frosty. I'm wondering if the light's blue. So we're going to see how to fix it. Because I don't know. I haven't worked on one, but we're going to try. I was a little concerned when I got it in the mail, or FedEx technically, because I don't know if you can hear that. I thought it was broken in the box because I could hear it. Apparently something inside is broken, casting probably, because nothing on the outside of this thing is broken. It is a huge piece, so if you don't have this piece, I'll lay it down. And we're going to move it on the camera so I can just kind of spaceballs. It's just too long to fit in the film. So without the spire, it is 18 inches tall. And with the spire, it is 24, just under a half. So about 24 and 7/16 maybe. So it is a very tall building. And it is almost 9 inches wide at the base. So if you don't have this piece, it's a very large piece. I've seen them. They don't look too big in displays if you do your display right, but it is a really big piece. So it is a 3-volt piece. And just like the, I know it broke. Now I know why it sounds funny in here. Let me slide this thing over. So this is a 3-volt bulb. It's like a 3-volt Christmas light inside of a glass bulb. Well, here's the 3-volt light, and here's the broken glass. So, but this is a 3-volt piece, and apparently this light shattered because it's clipped right here. And this is up inside, and then in shipping, it's bouncing around, and I bet you it smacked the inside, which in turn broke the glass. It's not going to hurt it. It's just to give it the effect of a light bulb instead of a Christmas light. But it's not going to hurt it at all. But it is a 3-volt system. Now, how are we going to fix this? How are we going to check those lights? First thing we're going to do is I see there's a plug in here. Let's get this plug out. Of course you can't see because the thing is bigger than my bench. There we go. Excuse me, bigger than the viewing area. I think that's all the way out. Oh, it's not. Hey, that's a lot better. Sorry about that. So I'm going to unplug the main lights, but again, now you can see it better. So this was shoved inside, and I bet you this smacked. Now you can see the whole thing. So it's just a 3-volt with a pigtail. It's one of their specialty mufflers that came with a double light. So we're going to move this away for now so it doesn't get more broken than it already is. And we're going to look inside. So this is a solid porcelain house. And I need to shine a flashlight in here so I can take a look. Okay. So alright, so this loom of wires right here, we have it as blue, green, yellow, red, orange, and brown. So there's 6 wires, plus the power, which comes off the lights that we just unhooked. They go to right about here, and then there's a big hunk of glue. So the yellow, red, and brown go all the way to the top. And that's what's hooked up for the lights that go up here in the spire. The other wires connect to a loom, and it's white and white with a black stripe, and that's what does these on the outer edge right here. And there is nothing holding that in that I can see except for glue. Way in there. I don't know how they did that. So now we need to figure out how they cast this where I've got some of the glass coming out. And set it down like so. So it looks like it's glued in from the top and they dropped the wire straight down. So let me get some magnifiers on so I get a better look, because it's small. Yeah, there's glue on the edges, so they glued the disc in with the wires already attached, and then they just dropped them all the way to the bottom, because this whole piece is one solid casting. Because of its age, I'm thinking the glue might just break free. If not, I'll have to heat it up. Circuit boards aren't the greatest to heat up, but it's used more for a distribution board of light than actual circuitry. They got glue actually on a couple of sides. Yeah, I'm gonna have to heat it up. So we're gonna turn on the heat pen. And once I get this out, I'll plug it back in, and I'm going to test the power going to the other lights to make sure that we actually have power coming up here. But again, the one's clear and the other ones are frosted, and that's not always a good sign. Now, this thing's almost too tall. I can barely get my pen up here. The cord's not long enough. Just move it over a little bit. There we go. There we go. The glue is changing colors. So what I'm doing is I'm trying to heat the glue up, and then I'm scraping out the glue. I really don't want to superheat the circuit board. I mean, it's not terribly hard to replace. Just you get a generic PCB board and cut it into a circle. You don't even need a PCB board. You can literally just solder the LEDs and then just hot glue them into the hole. But I'm going to try and salvage what's in here. I'm just letting you know a different option in case you have this piece and you have this problem, if this is the problem. This is the side that's going to be hard because they literally glued it right to the edge, which means there's more surface area. Oh, I think I got it. Good. Alright. Once that cools down, it'll turn off. If you've never watched my videos, it turns off after usually a minute or two. There we go. So now let's see if I can free up some of the glue in the bottom so I can actually pull this out the top. Instead, it's got a big glue chunk in here. So this part is going to be a little harder. We need to remove the slack, which is glued right on the inside edge, and I can kind of touch it with my finger, but my finger bends. Most tools don't. Some do. So first thing to do is I'm going to try a fish hook remover, and I'm going to see if I can grab some of the hot glue and peel it off. Got some of it off. I really don't want to have to put the the heat gun in here to help break this glue apart. Because if you heat up one side of a ceramic too hot, it can actually shatter or crack. But I might have to get some heat in here just for the fact that I don't want to break the wires by pulling on the wires or the glue. And ceramic's more forgiving to heat than like plastic. But you can definitely tell when your plastic's getting too hot. You really can't see anything with the... Yeah, there is a huge glob of glue in there. It's probably about the diameter of between a nickel and a dime. And it's right here in the base, right about where my finger is. So this row of windows right here, right in the middle. And I can see the glue shining through the top, because you gotta remember all these windows are opaque so that the light shines through. So my flashlight shines through beautifully. Yeah, it is a huge glob. Big old glob. So I am gonna put some heat in here and see if I can soften it enough I can pull it out. So So I have my heat pen set for 240 degrees Celsius. So that's rather toasty. But if I can heat it up quick enough, just the glue, I can get it hopefully to stretch and separate. At the same time, I don't want to melt the wires or fracture the porcelain. Now if you go too cold, you'll be here forever, and you'll make no progress, and you'll get frustrated and possibly break it. If you go too hot, you might heat it fast and then break everything. So just take your time. 240 is a decent temperature because it's a very small tip, as you can see. So if I had a wider tip or no tip, I would probably turn it down a hair. But I'm kind of pinpointing it into the area where the glue is. The glue that's holding the wires to themselves is separating, but the glue that's holding it to the actual porcelain isn't. But I need to separate them so I can pull that disc up and test the lights. I mean, the glue is sticky. You can see it's all over my tool now, but it's not releasing. Now this is the glue that I'm poking at, is that nickel size area. And this is the glue that's coming out. It is soft, but it just doesn't want to release the wires. Doesn't help that it's recessed inside the edge. I think the only reason they did it like this is to keep it from getting in the way of the lights. When you put them in and out, they don't get caught on the spring that pulls the lights in. starting to harden back up, so I'm going to put a little bit more heat in here. This is why a lot of these videos take time, because it takes time. I'm hoping it's just the LEDs are burned out, because if not, it means there's a problem with the switch and the little circuit board within the switch. And like the New York Times building, they don't have any repairs for those circuit boards. There's really not much you can do. But like I said, because those lights are frosty, I'm going to go with the lights. Because the lights are supposed to be clear. LEDs do fail. They don't last forever. And this piece is an older piece. It's 2003. Yep. So it's very possible that the LED is just fatigued. Plus the quality of LEDs have changed over the years, and LEDs in the 2000s aren't as good as LEDs in the 2020s. I got a little movement on it. So if you don't have a fish hook remover, since that's what I'm using, you can use 90-degree pliers, like long nose, needle nose, or hemostats. I have them in different sizes. A screwdriver kind of reaches, but it's not as flexible as that is. This has got some flex where I can kind of pull and put spring pressure on it. Heavy duty tweezers might work too. Matter of fact, I'll try those. I got these off of Temu. They're dog-legged and they're long. Comes as a 2-pack. Ones are straight and ones are long. I don't know if they have enough gripping force. They have enough to start peeling the glue out. There is another option you can do if you can't get it out, and I might have to do that because it's not coming out and I'm afraid of damaging the wires. I'm hoping they're not damaged already. Because they apparently balled them in the corner, so it's not like they just put the wire and looped it and put a glob. They made a circle and then pulled the wires out, and the glob is actually really thick. It's not it's the diameter of a nickel, but it's not as thick as a nickel. It's probably a good ½ an inch of glue. But the other option is that we know what color wires those are. You can actually cut the wires down here and splice in new wire, which might be the easiest option, so you don't have to fight with the glue. But I'm going to give the glue another minute or two of trying, and then I might just go to the cut and splice. Basically, we're going to add 6 inches of wire to the wire that's in here to make it more serviceable in the future if necessary, because even though new LEDs are technically better, they still don't last forever. Nothing lasts forever. I'm going to call it because I can see the wire stretching and I don't want the wires to break. So to make sure there is no damage to the wires that are already in there, I'm going to plug it in and make sure that the top wires still work, the top lights, sorry, and make sure we still have the red. Lights are on. Hey, the white one's working all of a sudden. It's flickering. Oh, there's the green. There's the red. Okay, that's kind of strange. So the lights work. Why is the white flickering though? Turn off some light to see it better. So that's white, and it's strobe light. There's green. There's red. Green is dimmer than I would expect. So I'm just turning off those lights there to see if the voltage changes and if this changes speed, to see if it's a power draw. Because even the green, it was dimmer and now it's slightly brighter, but that was before I disconnected it all. I'm wondering if there's a problem with the wiring. Alright, let's open up this little control box. So I'm going to turn this around. That way the control box fits in the groove of the porcelain. We'll leave the lights off for the moment. And I mean, technically, the only thing that should be in here is a chip that changes the color, meaning that it just sends a signal to one wire to the other. Yeah, right there. Okay, so it's a 4 position. On, one color, next color, then off. Turn the lights on so I can see what this is. There we go. The Texas Instrument chip. Look at the bottom, because there is little chips on the bottom. Transistor. We do have a component that doesn't look so good. It looks like a resistor might have melted. Or it's just the residue when they soldered it to the transistor. I think it's the residue because this other one's the same way. So there's 3 transistors. 1, 2, 3, 4 resistors. 5, missed one. 1, 2, 3, 4, 5. Yeah, 5. capacitor. Now let's test the board and see if the board is our problem too, or completely. So currently all the lights are off, so I'll turn this one off so we can see the lights. And this is DC. Remember, it's 3 volts input, so that means all the lights are going to be 3 volts or less. Red's usually like 2. Get the broken glass off the bench. There we go. And let's see what we got. So we have a whole bunch of wires because this is also the incoming power. So the incoming power wires are spliced. Feels like right about here where there's a bulge. And I don't think the board... Okay, so the power is there and there. So let's see which side is negative and which side is positive. Okay, so red is hot and blue is not. So blue is our negative and red is our positive. So all the LEDs are hooked up through the switch. So I don't know if they're negative switch or positive switch. A lot of them are negative switch, so we're going to check that first. So let's turn on the first light. What color we got? We got the flickering white. So we're going to go to red and yellow, 5 volts. Red and orange, 0. Red and brown, 0. Red and green, we got 3. So now we're going to press the switch again. And now we got green flashing, which is weird. So now we're going to do red and green. We have 0. We have 3 still. Right. Yep, 3. Red and brown, we have 5. Red and orange, we have 0. Red and yellow, we have 0. So yeah, I think they're negative switch. And last but not least, we got the solid red. Red and green, we got 3. Red and brown, we have 0. Red and orange, we have 0. Red and yellow, we have 0. That's strange. Red and orange, we have 2. So that should be the red LED. So now we're going to press it again. And red and orange should hopefully be 0. It is. Alright. Because my memory is not the strongest, I'm going to write it down. So red, blue is power. And we got red, green, red, brown, red, orange, red, yellow. So red, green, and just do R, brown, red, orange, and then red, yellow. This is what I do usually off camera, so you don't have to watch, but this is how I test this stuff to see what it is. So yeah, we have power on the first one, which is good. And then the rest of them should be, well, red, green, we got 3 volts right now. Red, brown, we have 5 volts. Red, orange, we have 0, and red, yellow, we have 0. And the green's on. So let's get it to where the lights are off. Lights are off. It says that when I push on the circuit board, I press the button, so I got to be careful how much tension I put on the meter probes to prevent it from switching the button. So now I should hopefully have 0 across the board. We've still got 3 on green. Nothing on brown, nothing on orange, and nothing on yellow. And yeah, I know that you can look at the bottom of this, but what I'm trying to do is make sure the board's putting out the proper power, because it could be a bad discrete component or a bad chip. And it's very possible that the green is what powers these. Okay, so with nothing on, I have power on the green only. White flashing. Nothing on brown. Nothing on orange. Nothing on yellow. Just on the green. No, it is the yellow. I just didn't have a good connection. So red, yellow is the white. Now we got green. Looks like the green is brown. That means the red should be orange. Yes. And that's constant. And that constant should be these lights here. So it's just a pass through. It's not going through the chip because those lights don't change when you press the buttons. We can verify that by looking inside the house too. So we're gonna tipper. Yep, brown, red, orange, and yellow go to the top. Brown, red, orange, and yellow. And brown, yeah, red for power. And then the green wire, which is constant power, and the red are T-tapped into these. So the top lights that are always orange. Well, here's the thing. Why are those LEDs flashing and not solid when it was solid originally, the green, when it started working after I played with the wiring inside? Here we go. Let's get you back on camera. Yeah, we lost the white. The green's not flashing that much anymore. It's also brighter. Now it's flashing. Green is brown. Let's check the brown wire here. is in the middle. We're sending way too much power to that green. Greens don't run at 5 volts. So the red is orange, which is the bottom one, of course. Volts, and the white flashed, and that's the yellow. I'm really wondering if it's just the connections are bad. They're oxidizing, and I'm thinking that might be part of our problem. I really do wish there was more slack, but you know, I mean, I got a little bit higher by getting some of that glue melted. I have had it where it has been just solder connections. I don't like the fact that the green LED says it's getting 5 volts. It's too high for green. Green is usually 3 or less. So what I'm going to do is I'm going to try and resolder the white and see if it stops the white from being intermittent. Not high yet. There we go, now it says it's hot. And it is. Alright, clean the tip. A little solder to the tip. We already got the flux. I'm going to see about melting in some new solder. Make sure I don't have a solder bridge. I need to move the wire out of the way. Yep, no solder bridge. Now, yeah, no white. That sucks. Okay. And the green is brown, right? Yeah. Let's try that one. I think I'm just gonna make a whole new top for this. Yeah, I really do think it's solder connections. Also said I don't like these lights. They're frosty, but they're working. They're frosty. So what I'm gonna do is find my LED box, which is probably buried at the moment, and get couple of new LEDs, and then disconnect this and solder in new lights, and probably connect some extension wires on it and test it again. Because normally when you have a flickering light, if it's flickering voltage coming from the chip, the meter will bounce. Analog meters are better at it than digital, but the digital meter will go like 2.2, 2.4, 2.1, 2.3, 2.0. You'll see the meter bounce back and forth. It's not bouncing by tenths of a volt. It's staying pretty solid. So I'm getting good power. At least that's the way the digital meter is reading. I don't know if I have an analog meter in here. I usually try to keep one just because they can pick up fluctuations in power better than digital. No, I do. It's made for testing batteries, but it has a 3 volt, and it has a 22 volt, and a 15 volt, and a 12 volt, and a 9 volt, and a 6 volt. So let's set it for 6 because the power supply is actually putting out 6 volts because there's not much of a load on it. And I know it sounds horrible when I move it, and that's because of the broken glass on the bench from the light bulb. I'm probably going to, when I pause the video to find my lights, I'm probably going to take this off and vacuum the bench and see if I can get some of the glass out of here. So it stops pouring all over my bench, because that's actually a glass bulb, not a plastic bulb. So, we know the outer two are full power. So, as you see, it's solid. The needle's not moving. And there's red. Red is the red and orange wire, and it should be solid because the light's solid. So we got red and orange. There we go. I know it says it needs power, but I have it on 6 volts. That's why I put on 3 volts. See, it's closer to the green. But we're going to do it on 6. So as I'm looking, well, we'll leave it on 3. I just want to see if it bounces. So now we're going to go, which is off. That should be white, which isn't coming on. So white is red and yellow. This is why I write it down, because again, there's too many things to try and remember. So red and yellow. Not even, uh-oh, I hit the button. Okay, that's white. Okay. Red. So 3 volts is too much because it's the float. See, needle solid. Now we'll do red and green, or sorry, red and brown for the green. Needle solid. So that's what see how the needle fluctuates if I move the needle, the probe? That's usually what it'll pick up when you have fluctuating power. So now we'll test it up here. So I know that the chip is sending out the right powers. Let's see if there's a break in the wire that's causing it to fluctuate. And that's probably why the lights started working when I was getting them hot, is because they were making connection. So I need to set this so I can read it too. The problem is these are shorter leads, and it's not like you can replace them because they're actually soldered inside. You know what I'll do? Just to give me a little height. Red off, so that should be white, and again white is red and yellow, so switch these to red and yellow. Okay, needle solid. Now we'll go to green, which is red and brown, so switch these back, red and brown, needle solid. It's not the most fancy tester in the world, but it works. This is just an old style battery tester. I don't even know where it came from. Commercial Electric. Trademarked. Had it for a while. It's a battery tester. You can test your button cells, your 9 volts, and then you can use your probes to test up to 22.5 volts. And it just tells you if they're batteries, if they're good or not. So it tells you regular, button cell lithium, nickel, cadmium. So that's why it's got the 3 arcs. So if you've never seen one before, it's just a battery tester. When you put your button cell in here, you squeeze this. So here's a 3 volt. Just show you. You put the in and then you squeeze it. Tells you this 3 volt battery is bad. And probably is actually. This one is not a clue, it's either a 3 or 1.5. And that one's good. 3. So, and that's, get rid of this battery. That's what this is designed to do. And then if we send it to 9 volt, it tells you positive and negative. So on the side of your battery it says positive. And we do this, it tells me I got a good battery. So if you've never seen one, you could sometimes find these around. It's just a battery tester. This will do the same thing, but it's more expensive. I think this was like $4 at Goodwill 10 years ago, so it's relatively cheap. But the whole point of it is that the needle will bounce if the power coming in bounces. But I got 4-strand LED wire here. The colors won't exactly match, so I'll have to make a note of the colors, and that way I can extend this so it's actually workable. Because what I'll do is I'll have to solder the wires onto the original wires with some heat shrink, drop it out the bottom to do it, then turn this upside down and try and fish them out of this hole, and then resolder them to this board once I put new LEDs on it. So that way it's more serviceable in the future. But anyhow, at almost 15 minutes in, this is where we're at. We get intermittent lights. The chip is putting out decent power. There is some discoloration on the board, but it looks like it's flux from when they soldered this together 22 years ago. I will just take some alcohol and clean it. I just use isopropyl alcohol. I use 99%. Anything above 91 is good. And a toothbrush, not the one you use every day for brushing your teeth. And I will clean the board. That does a few things. So it cleans any of the flux off, it cleans any corrosion off, and that way if there is a bridge of corrosion, meaning two of the contacts are touching each other because they're corroded, they should remove that and make sure that you don't have any potential shorts. So, and if you're going to solder something on there, you clean the area for the flux. So, all right, I'll be back momentarily while I get out my LEDs and work on this and extend this. So the LEDs, there are 3mm. So if you have this piece and one of them is broken or burned out, they're 3mm LEDs. They come in variety packs and they're huge. Usually they're 50 to 100 pieces each. These are small packs, and you can get them up to 1,000. So, but I'll link them below. But let me see what I can do here. Try and get these lights working. That way this can go back to its owner. And like I said, I'm going to go get my little handheld vacuum, and I'm going to see if I can suck some of the glass out of this so it stops getting on my bench, because I have a funny feeling that with like one of the shards here, I'm going to put my hand down and I'm going to stab myself with a piece of glass. So I'm going to do some work and clean up, and I'll be back momentarily. Okay, we're back with the Empire State Building. Here's the original white LED. So what I did is, instead of extending the wires, just in case you don't have the ability to do that at home, I used a rheostat to hold the board, the weight of the rheostat pulling on the other 2 wires that are still here, keep it high enough for me to work on. So the white wire and the red wire is the hot and the negative for the white, if you remember from this piece of paper. So when I hook this up to my machine, it worked for a second and then it quit, and if I jiggle it around it kind of works. So I think it's bad. So this is a brand new white LED, same size, and like I said, this one's frosty and this one's crystal clear. That's usually an indication. So the longer lead, if you haven't done LEDs, the longer lead, which is this one, is hot. or positive. So if I do this, I'll try and hold it. Look, it's not flashing. It's not flashing because it's the LEDs that are failing. So I'm probably going to replace all three. Because the green has an issue, which this one should be green. My dividers came apart, so well, this one says orange, so let's test it. I found my LED tester. Make it easier than using this. Make it easier than using the machine constantly, because sometimes you touch the connections and you have a problem. Yeah, so this one's orange. I don't know, camera's not really picking up the color right. So it's red, green, white. We got the red, should be right here. Plus these newer LEDs are technically brighter. Nope, that's yellow. That's why I have a tester. Yellow. Orange. Where's this guy? This is just one of my LED boxes, so this is a different shade of white. It's a warm white versus a cold white. Red, green. I mean, that one's green, but it's a dim green. I don't like it. I want to get a brighter green in there. And red. The camera has a harder time picking up the colors, which is a problem, but it is what it is. So my tester, you can buy an LED tester online, or you can make one with a 9-volt battery, a resistor, and a connector. So there's a resistor in here. It's right here, inside the tape. But anyway, I've used it in multiple videos. I also use the other one that has a push button, but I don't know where I put that. So I have multiple things because I lose stuff. It is what it is. So I'm going to change out some lights. So as you see here, I throw away the old white one so I don't accidentally use it. I have the rheostat putting pressure, so the board's up at an angle, and the yellow goes on the top because once I desoldered it, it rolled. The yellow is the negative, so we're going to take the longer lead and stick it through the center, because the center has 3 holes, and the shorter lead I'm going to stick through the outer edge like so and pull it through. Now I'm going to leave the longer lead on for now, because how they did this was these wires were soldered to the long leads and then they were trimmed. So this wire, like this orange one, isn't soldered to the board, it's soldered to the lead. The board does have a pad to help hold everything in place, but they actually soldered it to the leads. So now we're going to just solder the negative. I'm not going to solder the positive, so I'm going to solder the negative to the board. And that way it holds it in place, like so. And the reason I'm not going to solder the positive, and I'll try and show you. So I'm going to disconnect the rheostat. And I have the rheostat grabbing the board only. And I don't know where my shorter ones are because I'm sure those would be easier. I'm going to unplug this so I don't touch those two together, which become a short, and then possibly burn out that chip. So it's unplugged. And I'm going to turn this upside down. Ish. I'm going to zoom in a little. it's not really focusing because of the fact this thing is so tall. Zoom down, and we'll slide this over, and then focus. There we go. So let's use something smaller than my fat fingers. You can see, there we go, this flat disc. Let's see, can I get a little closer without it being out of focus? There we go. So as I move this, you can see the positive going through the disc, and you see there's another hole here, and there's another hole here. They still have the solder on it, and that's to hold the other LEDs in. So all I did is solder the outside edge to hold the negative, so I can do each one, and I can solder the yellow back on so that the wires don't fall through, therefore I don't need to extend them. And then I'm going to replace all three. The problem I'm having is the green is dim, and I can't, in my, at least this one kit, I don't have a brighter green. I know the green's bad too. With it unplugged, I just touched it and there was no light. The red I might have to keep because I don't have my clear reds. So you can see that they're clear lensed, all three. And then this is what I have. My clear reds, I've used them all apparently, at least in, again, this kit. I do have more LED kits, they're just not easily accessible at the moment. But I will still check. I do have red in the larger size. So here's a clear red in a 5mm, and you can see it's a huge difference. These will still work. You'll just have to raise them a little so that way when you put all three together they can flower out like petals where they kind of come out slightly at an angle so they don't interfere with each other because they're 2mm larger. These are 3s and these are 5s. And they make bigger. I mean, I have 8s and 10s, so at least I got the small ones in here. And they make smaller than these. They make surface mounts, which are 1/2 millimeter or 1/4 millimeter. They're itty bitty. So, but I wanted to show you that the other light didn't work, but this one does work without flickering. And again, it worked on my meter. I used my big machine, and it flashed, and then it went out. And then as I wiggled it, it would kind of flash and go out. So inside these lights is a very thin wire, and that's what makes the light. And I think it's broke. Or it's arcing, where the connection isn't fully broke, but it's touching and it's doing this. Don't know. I'm not cutting the LED open. It'll just shatter anyway. So, but that's how I'm doing it without extending the wires. I was thinking about it going, if I extend the wires and you're at home and you have this piece and you want to do it yourself, you're going to have a hard time. You definitely want something that you can put pressure on the board to keep it up and only desolder a couple of wires at a time. That way the wires always stay at the top and don't fall inside the unit itself. And then you'll need something like these rheostats to reach down the side and pull them back up. We're going to zoom back out. There we go. So these are my monster rheostats. I think they're like 18 inches long, 16 inches long. So I did have a smaller pair that were like 12, and I had another one that were like 8. I have no idea where they went. These are hard to lose because they're literally the same width as my drawer, and they just lay in this side. But anyhow, I wouldn't use vice grips because they're too heavy, and you might damage the finish or chip the porcelain. The rheostats are relatively light. They are still metal, so if you smack them, you can damage your porcelain. And I only have it on the first click, so there's 4 clicks, so I just have it on click number 1, which is just enough pressure to keep the board in the tip and hold it in place. If I go all the way, I'll imprint the board, and because of the edge of the board, I don't want the board to crack. So, or if you have somebody who's brave and wants to hold it with their fingers and trust you with a soldering iron, you can do it that way too. But they need to have some really good trust in you. So that's where we're at now. Like I said, I was thinking about it, and the whole point of this is to try and have you do it at home by yourself, where you can fix these objects, pieces, whatever they may be, because it's not just villages I do here. It's the majority, but some of the more recent videos of a Halloween phone or a 1980s toy. It's so you can try and use stuff you might have lying around the house, or can easily get off Amazon for just a couple dollars, or even hardware stores. Like, I don't know if you have a Harbor Freight near you, they sell rheostats. But anyhow, I'm going to look for my other LEDs, and I'm going to swap out the other colors, and then we'll come back and test it and go from there. You saw how I did this one. I'm just going to duplicate that for the green, and then again for the red once I find my clear lensed ones, and hopefully it'll be working like it's supposed to, and I can reassemble the switch and finish cleaning out the glass. I got a lot of it out, but not all of it. The inside's not smooth. It has lots of nooks and crannies, so you gotta like shake it around, and it's kind of a chore. None of my vacs really fit inside here. I have a little blower that fits in there, but I really want to blow glass shards all over the place. So, yeah. But anyhow, that's where we're at, and I shall return in a moment with hopefully all of them in and all the wires soldered back on, and I'm praying, fingers crossed, that we have red, green, and white with no flicker, and of course functioning like they're supposed to. Okay, I've soldered in 3 new LEDs, and white, green, red. See? No flicker, no flicker going dim and stuff, and still solid red. So the problem with this was the LEDs were dying because of their age, most likely. LEDs don't last forever. The modern LEDs say they can last up to 11 years, depending on how often you run them. I think they're supposed to be run like 2 or 3 hours a day, and blah blah blah. So I did find my other case of lights. Well, I knew where it was. I just had to move stuff to get to it. So they're all the clear 3mm, as you can see. Right now my hot glue gun is well, cold, so it's heating up at the moment. So I glue that in, and yeah, so not the easiest repair because of the shortness of the wire, so you got to be very patient and very mindful of where your soldering iron is, so you don't burn the wires that are there or damage the porcelain house itself. But it can be done, and it can be done without extending the wire, so I didn't have to use the LED wire. I mean, if you have to, you have to. Just I would drop the wire down through the top and out the bottom, solder it with heat shrink, and then pull the wire back through, and then add on, and then cut it where you want. That way you have your extension. So put the new wire down through the top, make sure it's longer than the house, probably twice as long to be honest. Pull everything out the bottom, solder your wires. Because this wires aren't the standard color code, write it down and say, okay, red, yellow, or yellow for the white, knowing it's negative, will now be blue. And then the red will be the red wire, and the green will be the green wire. And then or you can make the red the hot wire again, and make the black the red wire. Because most LED wires are red, green, blue, and black for RGB and ground. So, yeah. That way you can make an extension. You don't have to. There is actually technically enough slack, and it might be because I heated up the bottom to help pull some of it out. But you need to keep tension on it. So you can have somebody help you with a pair of needle nose pliers. If they're brave enough, grab them with their fingers. If not, something that clamps onto it that's not overly heavy or obnoxious, like rheostats, small ones. Even some small, they do make needle nose pliers that lock. I have a set. They're special. Or specialty, they're not special. They're usually used for wire twisting, but they're also very heavy compared to the rheostat. So it's a trade-off. But make do with what you got. That's the whole point of the channel, is try and fix it if you can without buying parts unless you have to, or buying special tools. Some medical kits come with miniature rheostats, which I think is strange because usually that's used for like pinching off something like a hemorrhage, but they come in handy for things, apparently, like this. So now, oops, caught on my watch. Now I just need to wait for this thing to get warm. It just takes a little longer. And then glue this on. I'm going to put the switch back together. I'm going to try and shake out more of the light chunks. And then we'll do a low light test to see what it looks like. In case you've never seen this piece. I'll do it while standing up, and then I'll tip it down and move it over, since the thing is bigger than my viewing window. And I'll hold it on, because this is only held on with gravity. It just got the 2 alignment studs, as you saw earlier, and it just sits in top. So when you tip it over, it'll have a tendency of falling out. But not terribly hard. It is moderately hard, only because of where it is and how you have to get it out with a heat gun or a heat pen, or you can try and just slowly chisel away the glue. But if you want to test your power from the switch, if you have an analog meter, use the analog meter. It will give you the pulsing if you're having a pulsing. It's not common. It usually means the chip is failing. So let's hope you just have a bad set of LEDs like this one did, and that's it. So I'm just putting 2 little dabs of glue, opposite ends of the circle, just like it had originally, and that's just so they can be replaced again. Because if you use something like super glue, you do risk it being a little bit more permanent. Just hold it for a second. There we go. You know what I'll do before I assemble it? Let's just do the light test, because it's 1 screw that holds that box together. Then I don't have to come back again. So, lights off. Plug the power supply in. Turn that off. Here's our white. Here's our green. There's our red. There's our off. Alright, so now I'm going to tip it so you get a side profile, or an angle profile. So I'm going to hold it. And we can still see it. Here's your white. There's your green. There's your red. There you go. And that is the Empire State Building with its lit top, and how to fix the LEDs if they fail on your piece. Again, not overly difficult. Can be done at home. You don't have to ship it to me and risk it getting shattered in shipping, because this came and I wasn't impressed with the packing. I don't know who packaged it, if it was an owner or FedEx, because the box was in the corner of the big box and all the packing was on one side, so there's no protection on 2 of the sides of this unit. And again, when I opened it up and took the box out that it sits in, I could hear it rattling, and I'm like, oh, I don't make it anymore. Luckily, it was just the bulb. Just the bulb. Not a big deal. The bulb is just to make it look like a bulb. It's just a Christmas light, low voltage Christmas light in a standard socket. Luckily, it will function just fine without the glass around it. It's just to give the appearance of a glass bulb, because like the bright lights factory, you need that internal light. You need this glass, even though it's colored green, red, to give it the light bulb look. Whereas now it's broke, it doesn't really matter. I'm going to unscrew this and chip some of the shards off, like right here. That way, in the future, if the bulb burns out and they get a replacement bulb, they don't potentially cut their fingers open on the glass, because again, these are glass. A lot of the replacements now, these are plastic. So, it is what it is. I didn't design it. I just know what it is. But, other than that, it's not, again, overly difficult. It's moderately difficult. It's only because of the limited length of wire. If you have a limited length of wire, go ahead and try and heat the wire up in the bottom to give yourself another couple of inches of slack. And then pop it off the top here. When I lived in New York, it was red more often than any other color. It was white, but it was more red, at least the times I saw it. So, because I used to see this when I lived out in New York. But, so we'll call it red for the end of the video here. You can do this at home. If you have any problems or questions, you can always email us at the RandomJChannel@gmail.com. So, there you go. in Empire State Building, how to test your switch. You saw me test it, even though it was a battery tester, analog and not a real voltmeter tester, to check for bounce. And then I showed you how to do the one light. I just did it 2 more times after that for the other 2. Was able to do it without extending the wire, and now without damaging the actual house itself. If you feel that hanging a rheostat off the side is going to damage it, you can use painter's tape. That way it's not as sticky across here. You can even tape on some gauze pads. You know, you can get the big squares of gauze or the roll, the gauze bandage, and wrap it around so when it leans, you're not worried about chipping the edge. I wasn't just dropping it, I was clamping it and then slowly resting it, and then I was making sure there was nothing over here that if I rotated the house that the rheostat would catch to drag it across the porcelain, since I can't find my short ones. As far as specialty tools, the screwdriver did reach, that's why there's still glue on it. This again is a fish hook remover. I think I bought it on Temu, but you can get them on Amazon too. The only thing I did that was different is I wrapped it in heat shrink for 2 reasons. 1, if you push too hard it tends to bow, and 2, if I'm putting it inside a house, especially a porcelain one, this prevents the metal from rubbing and causing chip damage. So, and that's just black heat shrink, just basically rubber. So there you go. That is the end of this video. Sorry it was so long, but I appreciate you watching. Until the next one.